Morning, morning. Still getting prepped. If you're in the live stream, feel free to drop a message in the chat and say hi. Or just start the questions coming. We'll get started really soon. Right, so let's get started. This is the second part of a two-part series, which is really just a testing ground for the material we're planning for the Beyond the Basics course for Pi System Administration. Today, we'll cover what we didn't cover last time. So here's what we ended up with last time. I'll make myself a little smaller here. Right. This is what we ended up with last time. In the first part to this series, we started off with 4 virtual machines, Pi.01, Pi-SRV01, Pi-SRV02, and Pi-SQL01, and discovered that it was a pretty insecure and badly implemented system, and we fixed up some of it. So we replaced the OPC interface with a read-only version. Over here. Our interface did have the ability to write back to our control system. We didn't like that. We fixed that up. And then we had it log in to the data archive using Windows credentials, even though it was off domain. So it's not on the same domain as our data archive. We had it log in using Windows Credential Manager. We switched it from using a very badly implemented trust to a mapping. And then that's when YouTube collapsed. So YouTube stopped working. Last time we did this, it went down completely worldwide. And then I stopped the stream. So we got about halfway through. So let's get to what we're doing today. All right. And by the way, feel free to type any questions in the chat as we're going. I'm going to go through the rest of this here today, which is we're going to install Asset Framework. So over here, we have only got a data archive in our network right now. We're going to install Asset Framework. Asset Framework essentially hosts a hierarchy of assets that users use to navigate the system. I like to think of Asset Framework as the user experience that users have when accessing the Pi system. Then after that, we will, while we set that up, we need to target a SQL database to use as a backend for Asset Framework. We're going to target this off server SQL database, and we're going to set that up as well. So we're going to set up a database inside this SQL Express here called PyFD. That will be written to by Asset Framework there. And then we're going to set up a highly available system. So we're going to set up an additional data archive and have these data archives sync up. And we're going to set up an additional Asset Framework server that will also target our backend SQL server. Okay, while we're setting all this up, I'll go over how everything works, and we'll go from there. One disclaimer here. While I'm going through this, you can follow along with me. There are links to subscriptions down below where you can boot up the same virtual environments that I'm using. I am using a completely clean boot of the virtual environment. So everything we did last time, upgrading the interface and securing the interface, the image I'm using, that won't be done. It'll still be using the old insecure setup. For what we're doing in this lesson, it doesn't really matter that we're using the old insecure setup. Really, the steps we're taking to improve this system, they could be done in any way. So we could install Asset Framework and set up redundancy before securing it if we really wanted to, if we were in real life. Okay. So let's get started. Let's see what we're doing. Our first step here is to install Asset Framework. Right. So my setup here, just so you can see what machine I'm on. There we go. My setup here, I have 4 virtual environments, or 4 virtual machines: SQL, PySRV01, PySRV02, and PyInt01. We're on PySRV01 to start off with. Let's take a little tour around here and remind ourselves of how this is all working. So I'm going to start up PySystem Management Tools here inside PySRV01. And once that loads, we're going to see if data is actually flowing, because I haven't checked that yet. It'll be fun if it's not. We'll have to fix some things. Also, not seeing any chat today, which is unusual. Feel free to say hi, ask questions, ask whatever you like. Okay. So here I'm going to go down into my current values underneath data. So PySystem Management Tools is an administration tool. If you've taken the basics course, you would have lived in here for quite a while. Here we go. Let's see all the tags we have on this system. We've got a bunch of tags here, all of these pump tags. These are coming from our OPC interface. Right. They're updating. I'm happy. I don't need to fix anything. If anyone is following along, type in the chat what issues you have and I'll help you troubleshoot through them. All right, let's set up Asset Framework. So this machine already has a data archive installed on it. We're going to install Asset Framework here and then set up our backend SQL server. So step number 1, we need to go into PyInstall-kits here and run the installer. So I'll right-click on the installer for PyServer and run as administrator. I'm going to do some configuration here, and then while it installs, I'll go over exactly what we're going to do with the backend SQL server. So we're modifying our installation here. We're going to install an additional Asset Framework server on top of Data Archive. So here it says Data Archive's installed. I want to also install Asset Framework server. Now, there's a reason I'm only installing Asset Framework and not the other two. We're actually going to install notifications and analysis service on our secondary machine when we install all the highly available stuff. So here we go. It's asking us about our SQL server. The SQL server we want to direct Asset Framework to as its backend is PySQL01/SQL Express. That's the SQL server we're going to set up. We want to install the scripts to set up that backend database, but we don't want to execute them. Now, there's a reason I'm doing it in this order. Before I explain this to you, it's going to take a while to install, and I'll explain how everything works while it's installing. I also don't want to validate the SQL Server version and the SQL AF database while it installs, because we're going to do that after. And okay. So we need to select a certificate for our RTQP engine. The RTQP engine essentially exposes Asset Framework as a SQL server for users to connect to with tools such as Power BI, Typico Spotfire, etc. We need to select a SSL certificate. This needs to be created by most likely your IT department beforehand, and conveniently our IT department has created one for us. And it's right here, the only certificate available on this machine. So we're going to go OK. And we're going to go next. The services. The services we have are group managed service accounts. They are called PySchool/PyAF. Let's see if I remember these off the top of my head and I don't need to check them. Wish me luck that I remembered those. They're incorrect. Now I'll have to go check them. So these group managed service accounts, we went over them in the basics course. They are created for us by IT. They're essentially accounts that we don't manage the password for. The domain manages the password. They're accounts that have been created on our domain where a specific service running on a specific machine is allowed to use those accounts and allowed to ask for the password for those accounts. We never know the password. Right. Just checking what these names are. Still no comments in the chat. This is very unusual. We have lots of viewers, but no questions. Strange things are happening today. Either that or my chat isn't working. Maybe that. All right, my chat is working. I'm just getting more and more sad. Okay. Let's see. Yes. They have a SVC prefix. So these are the accounts that have been created for us by our IT department. Should accept these. All right. So this is what's going to be installed. Really, the Asset Framework service and a bunch of SQL scripts that we're going to move over to the SQL server and run. All right. While that's running, and I'll make sure it is running, it is. Let's take a look at what we're actually going to do here. Installing an external SQL database. There's a few steps here. So up the top here is going to be my Asset Framework service server, and down here is our SQL server. When we install Asset Framework, it installs a bunch of things. So the Asset Framework service, that is a service that will run, and when users connect, essentially exposes a hierarchy of assets for them. It needs to connect to a backend SQL database, so we need to set that up. So this server has SQL Server running on it. We may as well name these specifically. This is Pi SQL 01, and this one is Pi SRV 01. Our Asset Framework service has to connect to something to store everything. So we're going to set this up down here in its SQL Server. When Asset Framework Service is installed, it'll also install a folder called SQL. Let's make this a little bigger. There we go. Essentially what we're going to do here is move this SQL folder, we'll make a copy of it after it's installed, over to our PySQL 01. Then we're going to log in as a SQL administrator, or as a database administrator. This is us. We're a DBA, database administrator. We're looking a little portly there. That's okay. We're going to log in, and we're going to run something in the SQL folder called go.bat. This go.bat is going to create a database on the SQL server called PyFD. That contains everything Asset Framework needs to service users. So when this is created, well, after this is created, we need to do a little bit of security setting up. We need to let this Asset Framework service in. So it's just a couple of extra steps there, and then we'll be golden. It should just work. Let's see how our install is going. It's completed successfully. I'll close that, and then I'll go and find this SQL folder. Well, first off, let's see what's been installed. Thank you, Sam, for the kind words. I am getting a little bit lonely. Right. We have AF application service here. It's running as the account we selected. That's great. So that's what's been installed. Well, it's one of the things that was installed when we ran that installer. The other thing was this folder full of scripts. So let's go and find that. I'm going into PySystem D drive, program files, PIPC, AF, and this SQL folder. Let's check out what's in there. It's a bunch of SQL scripts and this go.bat. We're going to move this whole folder to our SQL server. So I'm going to copy this. I'm going to put it in this shared folder. This is just a shared folder on the network. And then we'll move over to our SQL server and grab it out of that shared folder. So I'm moving to PySQL 01. open up our shared folder. There it is, and copy it to my desktop. Right. So we need to run this. I'm going to open up a command prompt. And just because I know I'm going to need it later, I'm going to start up SQL Server Management Studio. It takes a little while to start up. All right. So we need to go to desktop. And then we need to go to the SQL folder that we just moved over there. Then we run this go.bat file. So go.bat. And let's just run it and see what it says. So it says we don't have the right parameters, but it tells us what to do. So go.bat, then any optional parameters, and then the server we want to install the Asset Framework backend database on. And then the name of the database. So here we go, go.bat. And we have PySQL 01. SQL Express is our SQL server. And then our database name is going to be PyFD. So PyFD is traditionally used as the database name. I urge you to keep that database name. There's some legacy strangeness depending on what applications you're using, but really we could use any name here. We're going to keep with tradition and use PyFD as our database name. Okay, that should go through and run our scripts. Now, there's one little extra thing these scripts do. So while they're running, let's take a look at this. That's a bit better. So when we run these scripts, they are meant to create a local group. So on this machine, there's a group called PyAF servers. The scripts actually create this. And then you're supposed to put the servers account that runs the Asset Framework server in here. So that was the svc-pyaf account. Now, we're kind of trying to be close to real life here and assuming that you, as the DBA, don't have permission to create groups on PySQL 01. So we're going to do a little bit of a workaround that is really what you would do if you could not create groups on the PySQL, on the SQL server. We're going to explicitly give Asset Framework Service, the service account, a login to SQL Server and give it exactly what it needs. All right. And that's still going. Good evening, Adam, or good morning. We're still running. Okay. I did a little spoiler before. I said it wasn't going to be able to create groups, and it's finished with errors. The actual errors we get, well, I'm not going to bother checking the log. It's in there somewhere. The actual errors we get are in that error log. It says right there, and it says that it's failed to create the group and it can't configure security. So we're going to go and fix that. And just to confirm that it hasn't created the group, I'm going to go into computer management here. And local users and groups. And we have no AF servers group here. We have some other Pi related groups, but no AF servers group. So let's apply our workaround then. So conveniently, I started SQL Server Management Studio before. I'm going to log in. I am a database administrator at least. So I'm going to create a login for SQL Server for my Asset Framework Service account. I'm going to go to Security and Logins. I'm going to make a new login. Right. I'm going to search for the Asset Framework Service account here. So I'll search. And it's a little bit strange here, but I'm going to add or change the location to entire directory, not just this machine. And after I've changed the location, I can then select an object type up the top and add in service accounts for my search. Now I can search for the service account. And my service account is SVC by AF. There we go. Okay. So we've got it there. We want Windows authentication. And we need to go to user mapping now. So we're going to map it to a special permission in here for the PyFD database. So we're going to check PyFD. And then down the bottom, we're going to give it AF server and AF query engine permission. And that should be all we need. Just for fun, before I press OK here, I'm going to go back to PySRV01 and show you what will happen if security isn't configured properly. I'm going to attempt to open up PySystem Explorer. I'm going to get very unhappy. I thought it probably should get unhappy a little quicker than this. Come on, PSE. Break. There we go. All right. Cannot access SQL database. Could be caused by incorrect configuration of the database name or insufficient privileges. Right. So this is sort of what you see. Now I'm going to cancel that and go back and actually apply the security changes I made. So I'll apply that. So now SVC PyAF should have permission here. Back to PySRV01. Can I connect now? I may need to restart it. So one additional thing, the RTQP query engine, we are running that under a separate account. So we really should give that a login as well. I might close this and reopen it. Okay, that looks much, much better. Okay, it only contains a system configuration database. Would we like to create a new user database? Yes, we would. This is going to be called development. Okay. And we're in. So we use that. We've installed Asset Framework with a remote SQL server. Now, a note that I said before, we installed the RTQP service as a separate service. We really should, I had my notes written down a little wrong. This should have Asset Framework permission, and we should make a new login for the RTQP service. So I'll search for what we used for the RTQP service. SVC RTQP, and then give it query engine permission. Okay, that should make it work. So now we have the correct permissions here. And if we really want to be pedantic, we really should remove the query engine permission from the AF server service. Right. Okay. So our database is all set up. We should be able to do everything in Asset Framework that we usually need to be able to do. So just for fun, I'm going to go into library and create an element template. Template 1 will do, and then I'm going to check it in. I think I've proved to myself that it actually works. Fantastic. All right. Let's check out a little schedule now. So we've installed Asset Framework. That's the worst checkmark I've ever drawn. Okay. Next up is high availability. So we've got Data Archive high availability and Asset Framework high availability. Now, in the interests of time, I'm going to start the installation off and then explain how high availability works and exactly what we're going to do to configure it. We have here PySIV02. Right now that has nothing installed on it. We're going to install a PyData Archive and an Asset Framework server on there, and then configure them to be a redundant pair with PySIV01. Step 1 here is going to be install the software. So you need to install the same version of PyData Archive and Asset Framework server as your primary. Now, high availability for Asset Framework and for PyData Archive work very differently. I'll cover exactly how they work while it's getting installed. So let's head over to PySIV02 and start the installation. We're going to go into PyInstall kits. And we're going to run the installer for PyServer. Okay. We're going to go next. And we're going to have an all-you-can-eat here. We're installing everything. We're going to change the drive letters. So in real life, really, when choosing installation directories, and we went over this in the basics course, but when choosing installation directories, really you want everything installed on a different directory than your operating system, and preferably you want your data archives, which is the next step, to be on a different drive than everything else. Different physical drive. So we're changing everything to D drive. This machine has a few different volumes. It has C drive, D drive, E drive, and F drive that you shouldn't use because whenever the machine reboots, it loses everything from F drive. It's just how these virtual machines work. Okay. First up is our SQL configuration for Asset Framework. This is going to be a redundant Asset Framework service with our primary one. How redundant Asset Framework works is you simply set up two Asset Framework servers and point them to the same backend SQL database. So I'm going to point it to the same database that we just set up. And I don't need to install the scripts or execute them. All right. We can go next. Okay. It says that because we're installing the analysis feature, it needs to confirm the connection to the SQL database backend. We're okay with that. Next up is Data Archive. We're going to change everything to D except for the archive files. So first off, we need to find our Pi license on these training virtual machines. You need to navigate with the ellipsis. And it's in this training license folder. But in real life, you'd need to go to customers.ossf.com and then generate a license. Seeing as though this is a secondary, if you are licensed to have a secondary Pi data archive, you'll download a temporary secondary Pi license. And there'll be directions on how to do that on the website. Now, historical archives. These are all going on E drive. And queues, really these should be on a separate physical drive than the archives. I'm going to keep these in D drive. That looks pretty good to me. I'm going to go next. Right. This is setting up Pi notifications. On this setup, we do have an SMTP server. Our SMTP server is, because we've run out of machines, generally you wouldn't have an SMTP server running on a SQL server, but in this case we do. So PySQL01 is our SMTP server. And the from email we're going to set as notifications at PySQL.int. The notification service is responsible for sending out emails when certain events occur or certain events clear. For more information on those, check out our power user training streams on our learning website. We don't have PyVision installed in our network. If we did, we'd put the URL here just for an easy link to link people who receive emails from notifications to Vision dashboards. Okay. But this setup with email will be very different depending on where you're installing this. All right. Next up, RTQP engine certificate. We're going to select that. And IT has generously created a certificate for us on these machines. There it is. And we're okay with that. And service accounts. So we do a fair bit of typing here. AF application service was svc by AF. So again, all these accounts have been pre-created by our IT department. For more details on these accounts and how to create them and what you need, there are links in the basics course. And we're running notifications under the same AF account. In real life, we really should separate those out under separate accounts, but in our situation, we don't mind too much. PySchool, PyAnalyt for analysis service, and RGQP by RGQP. Okay. It's happy. That's great. Now we're going to install. All right. So while this installs, a little theory. How does high availability actually work? All right, let's see. Well, let's remove all this. First off, data archive high availability. We'll draw a little infrastructure like we always have over here, where this is our DCS, and this is our OPC server and OPC interface. Then we've got our PyData archive. So we may as well be a little more realistic here. Our OPC interface is installed on Py int 01 and Py srv 01 is our data archive. And data is flowing as we saw when we went into the administration tools and checked it out. Okay, system's happy for now. Now, when we add, I'll draw another little section here, which is the buffer subsystem, which has been configured and is enabled. So OPC server, OPC interface reads from the OPC server, sends data to the buffer, and the buffer sends data on to the PyData archive. Right. What we're going to do here, well, what we're doing here right now is we're installing an additional PyData archive on PySRv02. So we have a data archive here, and everything new I'm going to do in green. We're installing a new data archive here. And right now, well, when we're finished installing, this is what it'll look like. It's got nothing connected to it. It's just sitting there. We're going to come in. This is us using system management tools. We're using system management tools. We're going to use what's called a collective manager. And we're going to connect to both. And we're going to say, you're now a collective. So you're now a redundant pair. of servers. Collective Manager is going to initiate a backup. On PySRv01. It's then going to move that backup over to PySRv02 and do a restore on our second data archive. After that restore is complete, it's going to set up a configuration sync between these servers and declare them to be a collective. Once they're declared to be a collective, a few things happen. This interface, which is connected to through the buffer subsystem to the first data archive, suddenly says, oh, there's another server now, part of the same collective. So I'm going to start sending data to the second one as well. So one thing with data archive collectives, or redundant pairs, or you can have more than two if you really want to, of data archive servers is they don't synchronize the time series data coming from interfaces, or really any source. The only thing they synchronize over are tag configuration, security settings, and really everything else except for tuning parameters. And a couple of other bits and bobs. So that should instantly start sending data to our secondary, and we'll confirm that. Additionally, afterwards, any other users, so this is just a normal user, next time they attempt, maybe they're using Excel with data link, they connect up and want some data from this data archive. Their client now gets more information. It goes, oh, this is now a collective. Okay, I'll remember that for later. And the two collective members are PySRv01, and PySRv02. So they now know that. And this is completely opaque to the user. They don't need to do anything. Their client just suddenly knows that there's more than one server there. Now, how do collectives actually work when one server's down? So say we shut down PySRv01. It's shut down, it's completely offline. Next time the user tries to connect and grab data from PySRv01, well, first off, this data will start buffering and storing up, ready to be sent back to the data archive if needed. A user will try to connect to PySRv01, that'll fail. And then data link will automatically connect to the secondary. And the user will get their data. They'll actually not even know that there's been any kind of problem. So essentially what data archive high availability is, it's a user-side failover. And sorry, I missed the question that was just in chat. What's the mechanism behind HA? Hopefully this answers the question. Let me know if it does. So it's a user-side failover. These servers never actually fail over. They're not really aware of what the other server is doing. They just let users connect if they want to connect. This order of servers here, that can be configured, and that can even be pushed out as a registry key from IT. So you can have users in certain locations or specific groups of users that automatically go to the secondary for data if you want to. The only real differences between the primary and secondary are the primary is the only one where you can change configuration settings. You can't change any configuration settings except for tuning parameters on the secondary server. Okay. So feel free to throw any questions in the chat if anyone has any, and I can come back to this. But now we're going to start setting this up. Right. Well, we would be setting it up if it had actually finished installing. Maybe we can go over asset framework redundancy while it's still finishing. Okay. So here, let's look at asset framework, high availability, and how that works. So here we've got our Pi SQL 01. And here we've got our, maybe a little bigger, Pi SIV01. Here we've got Pi SIV02. Now, this SQL server has Pi FD in it. That's a database that we just created. And we have the asset framework service on Pi SIV01. The asset framework service connects to Pi FD. When a user connects, so they're using PSE and they want to see a hierarchy, they connect up. Asset framework queries Pi FD, grabs what it needs from it, and then serves them up what they asked for, the hierarchy or the pointers or the values or whatever. All right, so what do we do with high availability? We just installed, in fact, this is new, so we're going green now. We just installed an AF service on Pi SIV02 and told it that its asset framework backend is exactly the same database as Pi SIV01. And we ran it as the same service account, so it has the same permissions. And really, that's sort of all we need to do. If we wanted a kind of terrible user experience, that is. So this user running Pi System Explorer could connect to Pi SIV01 and get what they wanted, or they could connect to Pi SIV02 and get exactly the same hierarchy. They could also make changes on both Pi SIV01 and Pi SIV02. There's really no difference between the two services. There's no primary, there's no secondary. They're both equal members. They just both happen to connect to the same SQL backend. Right. In real life, really, I'll draw this more of a kind of cloud. This really shouldn't be a single server. It should be some kind of redundant multiple server setup of SQL Server. You can replicate the database in quite a few different ways. Our documentation tells you what's supported and what's not, but most methods of replicating a database are supported. If the asset framework servers can write to the replicated database, they will. So in general, we recommend the SQL always on configuration for the backend, which is, well, you can read about it in Microsoft's documentation. We only have a single server where we're sort of pretending that it's a large, redundant server farm with multiple redundant databases. Okay. There's one extra thing that we're going to do. So after all this is set up, we're going to take advantage of a network load balancer. So we have, I'll draw it a little bigger, we have Pi AF, which is a machine on our network. It has a network load balancer service installed. This network load balancer says if any connections come in on the asset framework ports 5450, 7 or 5459, and there's a bunch of others. Check our documentation for more details. Split it, or divvy up any connections that come in to Pi SIV01 and Pi SIV02. This way, a user will only need to connect to and know about one server name, Pi AF, and then suddenly they'll be using a highly available system. So that's how Asset Framework high availability works. Essentially, this is really no real setup for us. It'll just work. We're not going to go over configuration of the network load balancer in this session because that'll be different depending on what vendor you're using. The network load balancer is usually a piece of hardware. It can be a service running on a server, which we have in our situation, but there we go. This setup here is actually much more familiar to, well, anyone that's set up any kind of redundant web service or application service, a modern application service. You have a database backend, you have application front ends, and then you have a network load balancer dividing up the traffic between. It's how most things, at least web applications, work. So this should look very familiar to you. It's only really the data archive failover that looks a bit strange. That doesn't really have this kind of setup with network load balancers or anything like that. Okay. Let's see. We've finished installing, so we can go ahead and configure now. Right. First things first. Let's start up system management tools on this machine. See how it's cracking. Hi, Tony. Greetings from Perth. All right. Here we are. We can connect. That's a good sign. Really, this is the default configuration of a Pi server. We just installed it. We're going to have a play with the security before we make our collective, but I'm going to run into some problems, and then we're going to fix them in a bit. So we'll leave this here for now. On Pi SIV01, we're going to start configuring this collective. So to configure a collective, you need to run a Pi Collective Manager on a machine that isn't going to be the secondary member. So you can run it on any machine except for the one that's going to be the secondary member of the collective. So we're going to run Pi Collective Manager on Pi SIV01, which is going to be our primary member. Pi SIV01 also has some data already in its archive. We'd like to replicate that over. Hi, Rohit. Feel free to ask questions if you want to. Okay. Let's run Pi Collective Manager. Here it is. There we go. Okay, so we need to make a collective from our PySV01 and PySV02. Let's just go through and see what errors we encounter, and we're going to fix them as we go. So I'm going to go File, Create New Collective. Okay, so first off, it asks me if my backups are valid. Now, I'm going to go through how to do that. We're going to go and check out under Operation, Backups. Yeah, so Rohit, to answer your question, why can't we do this on the secondary? Why can't we run the collective manager on the secondary? Because part of the process is that all the Pi services need to stop on the secondary to perform the restore. And we need to be connected to the machine we need to be connected to the primary while that's happening. And that doesn't work because the machine's being switched off. Okay. Another question, the important thing to add in PySystem to be able to integrate programming with Python and Scala, maybe via API direct programming. I can go over, right after I've finished all of this, I can go over kind of a what connects to what diagram, how all of egress or ingress works programmatically. I can do that if needed, especially with all of this redundant stuff. Where does data come from and what connects to what? I can go over that at the end. All right. So we need to confirm our backups are valid. This is something that I've just gone to backups in system management tools, and I want to make everyone aware that this is not something that you should see in a production system. So no backup history found. Very bad. We should be backing up our system. Backups are fully covered in the basics course, where I could just say backup now and make sure we have a backup before we start doing this. It takes a little bit of time, so I'm not going to do it here. And it's not like I care about this training system, but you should care very much about your production system. Okay, so I've verified that I don't care if my backups are valid right now. And I verified my Pi interface servers configuration. This is saying your interfaces really need to be set up with the Pi buffer subsystem, and buffering needs to be working before we continue. Now, I haven't checked if buffering is working, so I'm going to go over to my interface machine now. If you are following along with the environment, you need to, it will fail to connect because it's off domain, this interface. You need to change the domain to pyint01 and type in the domain password. Right now, this is description exam teacher. If that changes, I'll write the new password down below if you're looking at this recording later. But right now it's description exam teacher. Okay, so we'll connect up and then make sure buffering's working before we go ahead and make this collective. I'm very happy that comments are coming into the chat. I'm not just talking to myself. I mean, I like talking to myself, but okay. So to confirm that buffering is working, I'm going to go to Pi interface configuration utility on my interface machine. Here we go. I'm going to go to Tools, Buffering. Okay. And there we go. This is a good sign. That's the amount of events that have been sent since the last time the buffer restarted. So that many events have been set to the data archive. And this 0 events in queue should pop up to a few events, then go back to 0. It depends on what's happening and throughput and if anything's if it's not able to catch up for a little while to what it's doing. I don't see it moving, but I see the total events sent increasing. That's really all I wanted to know. I'm getting data in my data archive for this interface. We checked that before, and buffering is working. Okay. So I've verified everything. Now, my primary contains data. I want to shift that data across to the secondary. So I'm going to select that. Okay, my collective primary is going to be PySRV01. I'm going to go next here. And my collective secondary, I can't select it because I just installed it on the other machine. PySRV01 doesn't know about it yet. I need to tell it that it exists. So I'm going to go to the 3 dots, the ellipsis here, and then add it in as another data archive server. So we go to add server. Network node is PySRV02. Oh dear. We can't connect to PySRV02. This is where I'd ask the class on how do we fix this. If anyone wants to type in the chat. I'm not sure what the delay is, probably a couple of minutes, and no one wants to sit there looking at me doing this, doing nothing for 2 minutes. So the reason why is a security problem. Username and password may be incorrect. Create trusts. Actually, from the lesson one, we don't want to create trusts. Never trusts. Yes, you so need a mapping from Tony. Thank you very much. Yeah. So on PySRV02, when it's installed, it uses the complete default settings for a PyData archive. So on mappings and trusts here, it's got no mappings. And it's got a single trust, proxy127. This trust maps all local connections to be an administrator. Now, in the first part of this live stream that happened a few weeks ago, we talked about why this is a bad thing. We do not want this here, and we fixed it on PySRV01. That was with a different set of VMs. It's been unfixed since, but we fixed that up. If you're interested in why this is really bad to have in your system, I suggest watching the first session of the live stream. It's linked below. Now, we don't really care about this right now. I don't want to go and fix security for the secondary. It's going to be completely removed and duplicated from the primary anyway. We just need a mapping for our administrator account so it's able to connect from PySRV01. So I'm on PySRV02. I'm going to make a new mapping for PySchool Student 01. That's the account we're logged in with. And it's going to be mapped to PyAdmins, which is a group that by default has administrative access to everything. We don't care too much about locking this down right now. Everything's going to be replicated anyway. So now we've got this. We can go back to PySRV01 and go OK. And it's been added in. We can connect to our PySRV02, and that's fine. We're connecting as an administrator. Fantastic. So we're selecting PySRV02 here, and we're adding it in. So we can have multiple secondaries. It's not too rare to have 3 or 4 secondaries. They can even be in different geographical regions. Keep in mind how the flow works though. Your interfaces are going to send data to both your primary and every secondary. They're going to, we call it fanning the data out. If they're in different geographical locations, you have to make sure that you have the bandwidth. that there are some workarounds you can do with a Pi-to-Pi interface and kind of send data from one server to another, but we're not going to cover that. We're not going to cover that right here. Right. So there's our secondary. We're going to go next. It asks us what we want to move over. In real life, we'll see tons of archives here. We choose what we want to move over. Generally, you do want to have copies of your archives on both machines, local copies of your archives on both machines. You'll also want, well, it depends on what kind of history you want to be available on the secondary. There's lots of things that come into this decision, but it's really up to you on what you want to move over. But you really have to move over the primary archive, the archive that's currently being written to, which is this one in our situation. We're going to go next. And this is where I really wish for these images I selected a different archive size. This is going to take a while to transfer between the VMs, but it'll be okay. So we're going to, when this happens, it's going to create that local backup on PySI v01 and move it over. Do we want to delete after we make that backup? I'm sure in our situation, you can keep it if you really want to. We're going to go next. And next. So a few permission things. The account that we're logged in as that's doing this needs Pi data archive access. It also needs permission to copy files from one machine to another. So Windows permissions as well. It's actually making that backup in a certain file location on the data archive and then moving that to the secondary machine. So you obviously need permission to be able to do that. Okay, so this is going to take a little while because I stupidly selected when I made these machines that we're going to have multiple gigabyte archives when really 50 megs would have done it. Something you've noticed on Azure or AWS machines is that you have to open the port 5450 for the collective to be created. Yeah, so we actually we need to be able to connect with this machine, with the machine we're running Collective Manager on port 5450 to both the primary and the secondary. Yeah, so port 5450 for the Pi data archive connections, and also any, I forget which ports that Windows file sharing uses, but actually copying the files from one machine to another. It's our user account and the Collective Manager application that does that copying. All right. So it's going to take a little while. Does anyone have any questions in the meantime? Right. Well, while that's happening, we can take a look at Asset Framework, because that'll be running on our primary at least. So here in Pi System Explorer, so now we're looking at Asset Framework high availability, and we came to the conclusion that it'll just be set up just automatically. Rohit, I went through this diagram before. If you scan back in the video when I was going through this is how there's actually quite a few ways that Asset Framework high availability can work, but modern recommendations is this way. You install multiple instances of the Asset Framework service, all pointing to the same SQL backend, and then you put a network load balancer in front of them. So we really just installed the second Asset Framework service, and all we're really going to do is open up Pi System Explorer and try and connect to the load balancer, and it'll just work. Well, unless I made a mistake setting up the load balancer, which I've been known to do. Right. Okay. It's finally copied the archive over. We may as well wait for it to start up again. After it copies it over, it sets up that synchronization and then starts up the secondary server again. Okay. Collective was successfully created. So we'll finish, and we can select PySRV01 here as the collective, and we can see some details about it. Once it's well and ready. The secondary might still be starting up. Well, it's at least going to PySRV02. We'll probably need to restart system management tools for it to pick up everything new. There we go. It says okay, secondary is available now. It was still starting up. Right. Let's see if SMT will just recognize that we've got a collective now. It does not. We're going to close and reopen it. Okay. There we go. So, here's our system now. If we open system management tools on any machine that knew about PySRV01 before, it now shows us two servers. I said before, when our client connected, here's our client up here. When our client connected, it automatically chose between the two. They were using data link. Any client application will do that. System management tools is special. With system management tools, you choose which server you want to connect to. So we're connecting to the primary here. I'm going to connect to the secondary as well. Now, this is very important. Once you've got a collective, when you are looking at if your tags are working or if they're not working, check on both. If a user complains to you that their tags aren't working, you really should be checking that tag on every one, because they may be looking at the secondary server and you might be looking at the primary and you're telling them, yeah, it's working for me. What's wrong with you? Okay, I'm doing a tag search. I'm going to search for really just all tags. Well, all OPC tags. There we go. So half of these will be on PySRV01 and half of them will be on PySRV02 if I expand the server out. Yeah. There we go. Okay. If I choose play, they're all in sync. So our interface is actually sending data to both servers now. And that all happened automatically when we configure the collective. Right. So we can go to our interface and see what's happening in the buffer manager now. We can go tools, buffering. And, because PySRV01 is our collective name, unfortunately, when that refreshes, it disappears, but we've got SRV01 and SRV02 now as well. So our interface now has two buffer queues. One that sends data to our primary, one that sends data to our secondary. If the connection breaks between the primary, the secondary will still be flowing data through, and buffering will be buffering data to our primary. All right. So that's PyData Archive high availability. Other things to note when we talk about when we're thinking about different services that send data to the PyData Archive, If you have any manual data entry data or any custom applications, you'll need to work out if those are going to start sending data to the primary and the secondary. If they do it through the data archive, if they do it through buffer subsystem, then they'll just simply start working. If they don't do it through buffer subsystem, if they do it through some other mechanism, then maybe some code will need to be rewritten. It depends on what your custom application is doing. Okay, let's take a look at Asset Framework. I'm going to, so here we've got Pi System Explorer open. And on PySIV02, just for fun, I'm going to open Pi System Explorer here as well. So keep in mind, PySIV02, we just installed Asset Framework and then pointed it at the PyFD database on PySQL 01 as its backend. So even though we just installed it and haven't actually done anything with it, we already have this development database and this element called, or this template called template1. That's because it's present in our backend SQL database. And all Asset Framework Service is a application service in front of a database backend. So now we've got PySIV01 and PySIV02. They have different names, but they contain exactly the same data. Well, they have the same nickname. What the nickname of the server here is actually, I may be lying. Yeah, I'm connecting to the wrong server. I can switch that over with, I'm on SRV02 right now. I can go show list. I'm going to, oh no, okay. Asset Framework servers do have nicknames. This is set at the Asset Framework database level. This server is called PySIV01, this sort of backend database name. The host I'm connecting to get this Asset Framework server is PySIV02, which is the local machine here. On PySIV01, here is, well, I don't know what this is. We can delete this. It's a temporary record. Okay. We have PySIV01 is the name and the host is localhost. So our two copies of Pi System Explorer on two different machines are pointing to two different hosts and getting the same Asset Framework database. All right. So just to have Pi System Explorer slightly less confused, I'm going to shut it down on PySIV01 and go and work on PySIV02. I'm going to go in to properties here. For this PySIV01, and I'm going to change the host it connects to and call it PyAF. Go apply and OK. So the host it's connecting to now is called PyAF, which is the name of our network load balancer. I'm also going to go into properties and rename the server, just so it's not confusing to users. Rename it. If I'm an admin, I can do this to PyAF. Okay. So now this is an Asset Framework server called PyAF, and the host is PyAF. When I add users to my, when I onboard users and install the Pi client tools on their machines, I'll have to make sure that the package I push out has PyAF as the host for the Asset Framework server. that way. Whenever users connect, they will connect to this network load balancer called PyAF, and then it'll redirect them to either, well, it'll connect on their behalf to PySRv01 or PySRv02. So I made those changes on PySRv02. Let's see if it still works. So we're in this PyAF now, in the development database, and we've still got our template 1, and we're all good. Let's see what happens when we try and connect again on PySRv01. So I'm going to open up PySystem Explorer. It says the server is now called PyAF, so the name has been modified. Now, because this machine knew about the server before, it would still use the old host name. So inside database, if I click on the ellipsis here, it's still connecting to the local machine for the AF database. If I wanted to make it connect to the load balancer, I'd need to change that here. I'm not going to do that right now. It can continue connecting to localhost. So what does this look like from a client setup perspective? Let's go to PySQL01. Now PySQL01 has PySystem Explorer installed on it. We're just going to use PySQL01 here as a client. It's really got nothing to do with Py other than this. We're going to open up PySystem Explorer on PySQL01. It actually knows about a different asset framework server. I said no, but it should still start up. Looks like it's not going to start up. I'll just say yes then. All right, so it knows about a different SQL server, a different asset framework database called SQL01. Let's see what the experience is like if we add this load balancer in to a client. So all of your clients that you install software on from now on, now you've got that redundant pair of redundant pair of asset framework servers. You'll just add an asset server and point it to PyAF and connect. And then it should just set itself up. At least it should. Okay. There we go. So PyAF is here, and there's a development database. Okay, so that was redundant asset framework. Now, so I got a couple of questions. Can you change the name of the collective and ensure the uppercase in the name is retained? I'm not sure about that. Most things in the Pi system are case insensitive. I know a lot of people get annoyed when the case is wrong, but generally the Pi system doesn't care. And if you try and change things from uppercase to lowercase, it goes, oh, that's the same, and it won't change. So there's renaming the collective name from from uppercase to lowercase, maybe name it to something else, and then rename it again back to what you wanted. But then users may not connect in between that time, and I don't think there's a really good solution to that, apart from maybe pushing out registry keys to users. All right. I'm going to take a very short break, 2 or 3 minutes. When I'm back, I'll answer some more questions, and I'll go through that diagram that I said I was going to go through, what connects to what, and how all this works in real life. Okay, I'll be right back. Hello again, everyone. All right. So let's see. There was a question before about ingress and egress programmatically. How does everything work? There's some details here that I also didn't go through and in what we did. So there's a couple of other things. When we installed Asset Framework on PySav 02, I'll switch over. When we installed Asset Framework on PySav 02, we also installed analytics and notifications. So these services we installed on PySav 02 generally in real life would probably want to separate these off onto another machine. Depends on how big our system is. So I was going to have a little chat on around when do we move things off? When do we add more servers? What I've got here is pretty spot on for a small-ish Pi system. As in, I don't like to use tag counts, but as in a smallish sized Pi system. I'm not going to give numbers here. For numbers, you'll have to send us an email. But let's take a look. Let's take a look at adding more infrastructure, or And if anyone has any more questions, then feel free to ask as well. So here, I may as well check these off. We have done our highly available data archive and asset framework setup. Now, these two servers, analytics and notifications, we installed these but didn't really configure them. Now, analytics will actually be, now we've set up the redundant pair of asset framework servers, it will be also connecting to the network load balancer for its asset framework to see what it needs to do to run calculations. Analytics is a service that sits there and looks at asset framework for calculations it's been told to run. It runs them and then writes out to the data archive. So one thing here, which we will need to configure for an analytics to work properly, is the buffer. Because we have a collective now, we want both members to get the results of any calculations analytics runs. So when it sends data, it should send data through a buffer subsystem to both data archives. We can configure that on our PySIV02. We run the buffer manager through Tools Buffering Manager on PySystem Explorer. Buffer subsystem hasn't been configured. Would I like to configure it now? Yes. And then we'd configure it and let it in security-wise to our servers. Now, I'm probably not going to do that here unless anyone's super interested. It'll involve configuring security a little on the data archive, making an identity, and then usually giving that identity by default write access to tags, although there are better and more secure ways we could do that. Right. So there's one thing that is a fairly popular request in classes, which is, now I've got all this set up, how does data actually flow? What happens when a user requests data? What happens when a calculation is run? What is written where? So I'll go through a quick whiteboard with every service we've got here, and then how it all works. Might use this one as a base. That'll do. Okay. Okay. Let's get some space in here. Let's make this one a little bigger. There we go. So our current infrastructure as it stands, we have a data archive in PySIV01. Shove this over here. And we have a data archive over in PySIV02. Okay. We also have asset framework in PySIV01 and PySIV02. And we have our little network load balancer called PyAF. Right. Now, just to avoid it being a spaghetti mess of lines when I draw the connections everywhere, we can just pretend PyAF is always redirecting to one of these two servers. So I'm going to put this down here. It's always going to redirect to one of the asset framework servers. For simplicity, and to make this less of a spaghetti mess, I'm going to assume we're installing asset analysis service on a different machine. And that can go here. I'm trying to think about how I'm going to solve the spaghetti mess problem. Okay. So right now our buffer here is going to our data archive. And there as well. Okay. Here we go. What connects to what? How does everything work in our system? We have a user here. Let's go through a few examples on how connections work. We have a user here. They are running data link as usual. It's probably the most simple example of an application. Data link is the Excel plugin for Pi. They're running data link and they want to grab some data. They connect up to asset framework. Let's change colors a little bit. They connect to asset framework and they attempt to do a search. Asset framework is here. They attempt to do a search. So they want to search through the hierarchy. In our situation here, asset framework connects to one of these two asset framework servers, and one of these two asset framework servers connects to our backend SQL server. All right. Maybe I'll make it connect to this one. So asset framework connects to our backend SQL server, and then it does a query there. It gets back the hierarchy of what the user wanted, and then it sends that through to the user, and they see these details in their search. Okay, so the user selects something, an attribute of one of our elements that was retrieved in the search. And they say, I want the current value of this to be here on my spreadsheet. The current value of this attribute. Now, what happens? How does that value of the attribute get into their spreadsheet? So more specifically, so they've selected a pump here. This is pump 1. And the attribute they selected is bearing temperature. Okay, what happens? So data link has got this bearing temperature attribute because it got it in its search. And it knows what the configuration of the attribute is. So this will probably be a PyPoint data reference configured attribute, and it'll be pointing to a tag. So PySRV01 p1.bt.pv. So that's our tag name. Data link would then initiate a connection to our data archive and say, what's the current value of p1bt.pv? Data archive will send back 6. Well, it'll look up in its archive what the current value is, in its snapshot. It'll send back 6. And then data link will put 6 there. So this is a common misconception with how connections work in the Pi system. The asset framework service and data archive service never actually talk to each other. one would assume that Asset Framework fetches that data on behalf of the user if they're using Asset Framework to do queries, but Data Link will do independent connections to both Asset Framework and Data Archive. Okay, so that's PyPoint data references. Say they wanted something else, which was the manufacturer of pump 1. Manufacturer, say that is a table lookup. To a table that's been linked from Asset Framework. So it's common to link Asset Framework through to a maintenance database of some kind. SAP, Maximo, there's a lot of vendors that have these maintenance databases. Let's see how that works. So the user asks AF, unlike the data archive one, the PyPoint data reference one, what is the value of the manufacturer of this pump? This query goes to one of our AF servers, whichever one happens to have its turn. And Asset Framework sees that this is a table lookup from an external table. Here we have some kind of external maintenance database with a bunch of tables. Asset Framework's been set up to link this table. It connects to the external maintenance database. It grabs either the entire table or part of the table, depending on how this linked table has been set up, and sends it all the way back to the user. This user's data link, well, it caches the entire table, grabs the piece of data they want from it, and then puts it in their spreadsheet. And this cache will hang around up until the cache interval that Asset Framework's been configured to use. So that's how table lookups work. All right. What about calculation results and how are calculations configured here? I'm going to assume that analysis has a buffer subsystem configured. When a calculation is set up, and I'm talking about analysis calculations here specifically, when a calculation is set up, a user will set up the calculation in Asset Framework. In turn, Asset Framework does its normal thing. So say the user has just set up this calculation called, well, I don't know, average, let's go maximum daily varying temperature, which is a calculation that they've set up to run once per day at midnight and then calculate the average over the day, or the maximum over the day bearing temperature for a pump. So when they set this up and they check it in, analysis actually connects to the load balancer here and goes, oh, I've got a new calculation. I've got this max daily bearing temperature calculation. So it gets the details for the calculation and then runs it. Throughout running that calculation, it will probably see that it needs to grab the bearing temperature. So analysis goes direct to the data archive and says, what's the average of bearing temperature over 24 hours, depending on how the formula is configured. Data archive returns to analysis, I don't know, 80. Analysis goes, okay, so 80 is the result of my calculation. Now I need to write it to a tag. So it goes to the data archive and goes, okay, I'd like to write 80 to my configured tag. So when the user created this calculation, they configured a tag called maybe daily MD max daily P1 bearing temperature. So analysis tries to write to that tag. If the tag doesn't exist, in fact, it kind of does this when it starts for the first time. If the tag doesn't exist, it'll attempt to create it. So it'll create this tag called md.p1.bt in the data archive, and then it'll attempt to write to it. This is where preferences may change from system to system. Best practice, I'd say, is to not allow the analysis server to create the tag and give that responsibility to the administrator. So the administrator should create this tag manually, or through PySystem Explorer. It'll let you do that as well. So generally, you don't give analysis permission to create tags, but expect the administrator to create the tag with the permission allowing the analysis server to write to it. So when it tries to write this 80, it'll write it to its buffer, and the buffer will fan the data out to both data archives. Okay. So both these data archives now have 80 in their value for their md.p1.bt. And when a user wants to get a value of this in the future, all they'll do, they'll connect to Asset Framework, which does its usual thing, finds out that it's a pipeline data reference, and then the user will go and grab the value for that. So that's 80, and it'll be delivered straight back to the user. So no calculation done after the fact. You set up these analysis calculations really to, well, not offload the processing for these calculations, but more to strategically time them. So this is a fairly expensive calculation. Well, it's not that expensive, but it's an expensive calculation. It's looking at historical data. So this user has made it run once per day at midnight and then saved the value in the PyData archive after the fact. Now, there are other ways you can do calculations in Asset Framework, and you can configure them to be done ad hoc, done just in time when the user tries to look at them. I'm probably not going to go over the data flow there, but generally when that happens, the data flow is almost always the calculation is executed when the user looks at it, either on the data archive or the analysis server, or the client itself, depending on how the calculation is conducted. So there's more information on all of this calculation stuff in our Power User course series, which covers Asset Framework and analytics. Okay. Now, that's really what I wanted to go over with what connects to what and how things work. Programmatic access was mentioned as well. So I'll quickly go over the options there. With programmatic access, you've got a few options. Really, I'm talking the modern system here. Really all you should be developing with if you're starting new projects. Your options are really AF SDK, which is a native .NET, library. most of our client applications are coded using these same libraries that we allow our customers and partners to use. So if you're writing a Windows application, or you can reference .NET libraries from Python if you run it on Windows, you can use the AF SDK, which is completely full-featured. You can really do anything any of our clients can do using AF SDK. So that's an option. Python was specifically mentioned by the question. If you're interested in running .NET through Python, there's a great blog post. There's a great blog post that you can take a look at on PySquare. So I suggest Google it. Google running AF SDK in Python, and you'll find it. Other ways of programmatic access, we have really RTQP, which stands for Real-Time Query Processing, usually has engine on the end. The R2QP engine, which really gives you SQL access. So OLEDB, ODBC, or JDBC access to Asset Framework, really. So essentially you'll have Power BI or something like that, Microsoft Power BI. You'll get that to run a SQL query on the RTQP engine in Asset Framework, and then that will give you the data you need. Asset Framework will connect to there, which actually connects to the RTQP service, not the AF service, if you're making a query there. And then that will in turn connect to Asset Framework and Data Archive and the SQL backend to give you the results you want from your query. So that's an option for programmatic access as well. And there is also Web API. Now, we didn't install it in this session, or it's not installed in our system right now, but you would install a Web API service. The Web API service responds to RESTful calls, so HTTP, HTTPS queries. Usually you'd use this if you're running a web application, something on Linux or non-Windows environment, or really anything that can make HTTPS calls to a web server can use PyWeb API to grab data. Generally, it's just a big URL that you'll strategically configure, and then it'll return you the data you ask for in JSON format. So this person, maybe they're coding a web application now, or they're using a custom web app that's been created, that's been generated by one of our customers or partners. This web app connects directly to PyWeb API. Their browser does, and does these queries, and PyWeb API connects to Asset Framework and Data Archive where it needs to. Grabs data, returns it back to the user. You can also put a network load balancer in front of PyWeb API. Okay, now, I think that's all the questions that were in the chat. And this is really all I had planned for the session today. Now, this was really a sort of rehearsal for our Pi System Administration Basics. This is really sort of a rehearsal for our Pi System Administration Basics class. It'll be released within the next few months. The content from our first live stream, I've actually re-recorded that and then built part of the class already. I'm currently recording this section and then building the rest of the class here. If anyone has any questions or anything they think we should cover in this class, please comment in the chat right now, or comments down below if you're looking at the recording of this session. I think I'm going to sign off now. And really, if you have any questions regarding anything that we went over here, post them down below. Who knows? I might do another live stream if there's interest. Okay. And unless there's any more questions, with that, I'll sign off. So thank you, everyone, and have fun administering the system.